Right, let's get to 3.3. So we're dealing with sequences and series. Here, what we notice, what we should notice, right, is that there's this infinity thing over here. Right, so this is the sum to infinity. Sum to infinity, we should understand that if there's a value here, it means that this converges, right? Okay, so what does converge mean? Or rather, which sequences converge? Only geometric sequences converge, and they only converge when R is in between -1 and 1. Okay, so maybe we can even test this to find out if this is a geometric sequence, and if it does converge. Let's go ahead and do this. Let's take out the Soviet. So let's get the Soviet. That is Tn, right? So Tn is expressed by that part of the equation. This part that's over here, k equals, I think that's a 2 over there. That tells me where I start with my k values, and that infinity above there tells me where I stop. All right, so our first term, if we want to express this out as our series, let's put the k value, which is 2, into this equation over here. So this will be 3 to the power of -2 divided by 3n. Okay, we can leave it like that. That can simplify though, because we don't like negative exponents, so this thing can go to the bottom. Let's just do that again. This thing can go to the bottom. So this would look like this, 1 divided by 3 squared times 3 to the power of n. That would be our first term. Okay, right. How would the second term look? So we can again go to that equation there, and instead of a 2, we're going to substitute the next value, which is going to be a 3. So then it would be 3 to the power of -3 divided by 3n. Again, this thing goes down. So our second term, that thing would equal to 1 divided by 3 to the power of +3 times 3n. Right, so there's term 2. Term 3, similarly, you just go put a 4 in there, right? And I can already see the pattern that's being formed over here. This will look like this: 1 divided by 3 to the power of 4 times 3 to the power of n. Right, so that's the sequence that we can see over there. Again, or rather, in the previous video, we spoke about how to find R, right? And R was your consecutive terms, so it's second one divided by first one. So let's take that quickly. So the second one is 1 divided by 3 to the power of 3 times 3 to the power of n. And let's divide this, divide by our first term, which is 1 divided by 3 squared times 3 to the power of n. Okay, we know dividing fractions is the same as multiplying with reciprocals. So we are going to leave the first one the same: 3 cubed times 3 to the power of n. The division, we change to multiplication, we take the reciprocal, so this 3 squared is on top now. And we have 3 to the power of n also on top, divided by 1. So we can see that that cancels with that. 2 of these cancels with 2 of those, so you are left with a 1 there. And this simplifies, so your R value simplifies to 1 over 3. Right, so that helps us. We have R. We also have this value over here, which was A. We have A, we have R. Um, and then we can find our sum to infinity. So we'll say sum to infinity. We know that that formula is going to be A divided by 1 minus R, right? That formula is also given to you on the formula sheet. So now we just need to do our substitutions. Our A value was 1 divided by, let's just go double check, 3 squared, 3 squared, 3 to the power of n. And all of this gets divided by 1 minus our R value, which is 1 over 3. All right, so let's just do some manipulation over here. Let's take this 1 over here, and we're gonna rewrite it as 3 over 3. Okay, so now what I've got, my numerator, I'm gonna write exactly the same: 1 over 3 squared times 3 to the power of n. multiply it. So I'm going to take the reciprocal of my denominator. If my denominator simplifies, that's going to be 2 divided by 3. The reciprocal of 2 divided by 3 is 3 divided by 2. Okay, so again, this 3 cancels with one of those. So what do I have left? What do I have left? I have 1 divided by 3 to the power of 1 times 3 to the power of n times 2. Right, yes, 3 times 2 is going to be 6, but let's just check what we want it to end up looking like. Alright, so we see it needs to look like this. So we are going to apply our first exponential law. So let's go back to the bottom over here. We're going to apply our first exponential law, and these bases are the same, multiplying. So we're going to add our exponents. All right, so we'll say this is equal to 1 divided by 3 to the power of 1 plus n times 2. And that's what you wanted.